Hi, welcome to lesson 1.4 where we talk about curve sketching. Now this is actually mostly a review. You should have learned most of this in secondary math 3. So we're going to review a couple vocabulary words right up here. First one is domain. Domain is all the possible x values. We need to make sure that we don't have any 0 in the denominators and no negatives in our square roots. We also have vertical asymptotes. Most common vertical asymptotes is things that make the denominator 0. We always write them as an equation, x equals a. Next, any wholes. You get a whole when you have a function where a factor on top and a factor on bottom cancel, and that makes a whole at whatever x makes that 0. So this would be a whole at -3. X-intercepts are when y equals 0, we write it as an ordered pair. Y-intercepts are when x equals 0, write it as an ordered pair. End behavior, we always have two end behavior sentences. They should look familiar. It's limit as x goes to infinity and as x goes to negative infinity. So what you're basically saying with both of these is how are the ends of our graph behaving. So we have the right end all the way to infinity, the left end all the way to negative infinity. How are those ends behaving on our graph? And then we also have even and odd. Even reflects across the y-axis, odd reflects across both. So let's look at some examples. In these examples, we're just going through and listing these things. We don't have to sketch anything yet. Right now we're just practicing listing them. Now there is a order to this that will make this easier. So this is the order I would suggest. Do asymptotes first, then domain. And here's why. If I go to simplify this, so simplifying would mean I want to take an x out of that, take out the greatest common factor. So I have x plus 2 over x times x minus 2. Now, first things first, look at that simplified version. Do I have anything that cancels out to make a whole? In this one, I do not. I don't have anything that's exactly the same. Now I look in the denominator, and I think, what x's would make my denominator 0? Well, if x is 0, the denominator is 0, if I plug in 0. And if x is 2, if I plug in 2, I also get 0. So those are my asymptotes. Now for your domain, you can say it's going to go from negative infinity up to 0, because then I have an asymptote. I'm not going to do a bracket. I'm going to do a parentheses, because my graph gets close to 0 but never touches. Then it's going to go from 0 to 2. Then I have another asymptote that I'm never going to touch. And then from 2 to infinity. So if you do those asymptotes first, then your domain kind of comes a little easier. Okay, end behavior. I have limit as x goes to infinity of f of x, and limit as x goes to infinity, of negative infinity of f of x. Now, to find end behavior, this is where I compare my greatest terms. So when I'm thinking as x goes to infinity, if I have this function, and I'm thinking as x goes to infinity, a really, really big number, this 2 is basically inconsequential at that point. It doesn't even matter because x is infinity. So that 2 can just go away. It gets canceled out. And when we look at this bottom one, at infinity, x squared is going to grow so much faster than negative 2x. So we can just get rid of that. That's why we're only looking at the biggest terms, because at infinity, the biggest terms are the ones that grow the fastest. That's the key to this. What grows the fastest? So then I come here. I have x over x squared, which simplifies to 1 over x. Now I think about this. if this is what I have as x goes to infinity, so like 1 over 1 trillion, that number is getting closer and closer to 0. And it doesn't matter if it's negative infinity. 1 over negative 1 trillion is still getting closer and closer to 0. So that's how I would write those out. Try number 2 on your own, pause the video, and then come back and see if you got it right. Okay, for this one, we have a vertical asymptote at -3. That's what makes the denominator 0. So our domain is going to go from negative infinity to -3 and -3 to infinity. Basically all the numbers, except we're never going to touch -3 because it's an asymptote. Now let's look at the end behavior. For this end behavior, the biggest term on top is 2x cubed. For on bottom, if I were to multiply this out, the biggest term would be x squared. Now I could multiply it out all the way, but I don't care about the rest of them because at infinity they're inconsequential. We only care about the biggest term, which would be an x squared. If I simplify that, I get 2x over 1. Now think about the graph of this. 2x over 1 would look kind of like this. So what this graph is saying is this is showing you what the ends of the graph are going to do. So if I were to graph this equation as I go to the left, infinity, this graph is going to go up to infinity. So limit as x goes to infinity would be infinity. Then as I go to the left, negative infinity, this graph is going down, negative infinity. So I get that one. So if you simplify it this way, you get 2x. Think of what the graph looks like. That's what your end behavior is doing. So if you simplify it to x squared, then your end behavior would both go up. They would both go up to infinity. In the next video, we'll try this little more complicated one where we got some holes.